We are moving ahead with our next session. Session Chairman, Mr. Ravi Dole, sir, Castco Kolhapur, I'd like to request to escort our another speaker, Ms. Tejashree Joshi, Godrej Boyce Manufacturing Cooperative Limited, Mumbai. Please put your hands together for Ms. Tejashree Joshi. And as we can see, so the lovely ladies present over here, all my speakers. So we are truly inspired by your presence. Yesterday we were having the sessions where the men were talking more and we were listening, and today the tables have turned and we have our ladies who are here to talk about such a delicate and important topic, really for our health, for our industry, for our founder men of India. We are really glad, we're truly humbled by your presence. Thank you so much to discuss on the boosting Foundry sustainability is such an important topic for our founder men, all the people who are here attending this 2-day seminar, and truly a woman-dominating session we are going to have, and our representative, none other than Ms. Tejashree Joshi. I'd like to, before I request her, let's look at her AV first.
Ms. Tejashree Joshi. Ms. Joshi is a technical graduate from Environmental Engineering branch. Tejashree Joshi heads Environmental Sustainability at Godrej and Boyce Manufacturing Company Limited. With 20 years of experience, she has facilitated strategy development, target setting and achievement under Godrej and Boyce's sustainability initiative of Good and Green Vision, which includes achieving zero waste to landfill, carbon neutrality, positive water balance, reducing energy and water consumption, improving energy productivity, and increasing renewable energy use, and charting out a low-carbon pathway for businesses. Tejashree leads programs like environmental studies and planning for new establishments and projects, design, development, and implementation of environmental management systems, and is also responsible for managing environmental legal compliance performance across all businesses, and is also responsible for managing environmental legal compliance performance across all businesses of Godrej and Boyce, and ensuring extended producers responsibility EPR conformance for e-waste and plastic waste. She represents Godrej and Boyce in the India Plastic Pact initiative. She supports facilitation of green buildings and product certification, life cycle assessment and sustainability reporting for environmental indicators under GRI standards framework for the organization. She is in charge of the Godrej wetlands management, mangroves and biodiversity enhancement. Under her leadership, Godrej has undertaken many first-of-its-kind biodiversity initiatives like estimation of carbon sequestration capacity of Godrej mangroves and terrestrial green cover, development of biodiversity index for Godrej Vikhroli campus, ideating for creation and enhancement of biodiversity hotspots and theme gardens, mangroves and other terrestrial afforestation projects, development of mangroves app, first by any corporate in the world, and mangroves children's storybook. She represents Godrej and Boyce in the India Business and Biodiversity Initiative IBBI, a flagship program by Confederation of Indian Industries CII for mainstreaming biodiversity consciousness in Indian businesses. Ms. Joshi holds a Bachelor of Engineering degree in Environmental Stream and a Master's Diploma in Business Management.
Thank you so much. So I'd like to request Ms. Tejashree Joshi, please conduct the session.
And good afternoon, gentlemen and ladies. Yeah, I know I'm standing between you and lunch, so that's the biggest challenge I have to how do I still keep your focus on this very important topic while you are craving for energy for the next sessions. And therefore, I will probably take it a little faster. I have too many slides to talk on. But however, I'll be leaving the presentation with the organizers, so you can always have access to it if you are more interested in the subject. So the session just concluded was talking about well-being of us humans. I'm talking about a topic which is the well-being of this earth or the planet that we habitat. And unfortunately, the stress for this planet is us, Homo sapiens. And therefore, I think it is very important to connect the two things. And while we talk about our own well-being, let us also talk about this ecosystem which is sustaining all of us and will be sustaining our future generations. Yeah, I think it's working now. Okay, so you all have been hearing, and I'm sure all of you have heard so many people talk about a lot of things. And one of that is global warming. And I think it is one word which has been spoken about so much, but do we really realize why global warming is very important? And let's set the context a bit. Here we are talking about talking about the entire globe warming because of anthropogenic activities. And what other anthropogenic activities means: man-induced or human-induced activities which are creating this change in the climate. And we've been experiencing this every year nowadays, last 4 or 5 years, erratic climate change. There are cyclones, there are many other extreme environmental events. And a lot of these are getting attributed to human activities, which is going beyond the natural assimilation capacity of the earth. And just look at the chart that I'm put up here. See, Earth's temperature has risen by 0.08% degrees per decade since 1880. And the rate of warming that we are seeing has, since 1981, is more than twice, that is 0.18 degrees Celsius per decade. Now you'll say this differential is very, very minuscule. It's just 0.08 and 0.18 degrees. How is it impacting us? Just understand that the heat which is generated on the surface of the earth is basically stored in our oceans. And when it is stored, just imagine the quantum of heat that is generated, that it is rising the temperature of the surface of the earth, which is translated from the oceans to the surface of the earth, and it is rising by 0.18 degrees centigrade. The sheer amount of heat that the planet is holding today to make this rise happen. And therefore, even a minuscule rise in temperature creates large environmental events and impacts, which actually really impacts those vulnerable communities who are having very less capacity to basically bear these changes. And things which are created in one part of the earth is impacting the other location. And therefore, this is truly a global problem. But we'll look at what do we as individuals need to do in this to mitigate this. Now, average across land and oceans in 2001, the surface temperature was 0.84 degrees centigrade, warmer than the, what we're talking about, the 20th century average of 13.9 degrees centigrade. And 1.04 degrees centigrade warmer than the pre-industrial area. So between 1880 and 1900 is what we call as a pre-industrial era. And today you would have heard everyone speak about the Paris Agreement, the climate action, reducing the warming to, or holding the warming to 1.5 degrees centigrade. So this is the baseline which is considered when we say the warming of the earth by 1.5 degrees is with this baseline. And that's where everybody wants to move to avoid the major impacts of climate change that will impact all the nations. So since 9 years, from 2013 to 2021, these have been ranked as one of the most warmest years on record. And therefore, we are seeing this change because of so many activities, and we are also seeing the impacts of these changes. Yeah. So, now let us look at a little granular when we're talking about what I was talking about, the climate change. See this graph. This is talking about a global surface average surface temperature. 1880s to 1980s, most of the time, the temperatures of the globe was a little below the average that we are talking about for the global temperature. And post 1980s and 1990s rather, the industrialization which started happening in the developing world also has contributed, and you can see the rise of temperature that it is creating. And this is where it puts into context what is happening today. Developing economies are on a global growth path. We are on a rapid growth trajectory, which is going to have its impact on ecology and environment, and this is what it is resulting in. So we need to be conscious of what impact we are creating because of our activities and take measures so that these impacts are minimized, they are mitigated, and at times offsetted by actions that we will take or investments that we will do in sustainable future. So what is really needed? Like, we need to go on diet plans for our health. The planet really needs to go on a carbon diet. That means I'm talking about reducing the emission of carbons that are happening, or rather sequestering the carbon which is there in the atmosphere. So the past burning of fossil fuels, including coal and natural gas, has released greenhouse gases into the atmosphere that has caused the earth to warm to 2 degrees Fahrenheit. That is a bit more than 1 degree Celsius since the pre-industrial area. So we have already done that damage. Now what we are trying to do basically is to curtail that damage and keep it limited to 1.5 degree, and which is a huge task. You would have heard a lot of terminologies in terms of net zero, in terms of minimizing the impact, and this is where it is leading to. If we are able to cap our carbon emissions to 1.5 degrees Celsius, we have a chance of going to net zero. And as countries, as regions, we are taking these commitments to have net zero carbon emissions by certain years. India is committed to 2070, and with the kind of growing economy that we have, the kind of number of people that we have, and access to these basic needs that people have, it is a very, very challenging and a daunting task for a country like India to achieve net zero by 2070. While government does its parts with its policies, it is imperative that industry, we support the government's plan on this, and for that, industry needs to take even more stringent targets than what government has taken. And therefore, this whole drive through various industry associations on pursuing this path of carbon neutrality or net zero. So there are again, just a bit to explain what are the two terms which normally people are using, and this you would hear more and more. Your customers will start asking you for this more and more as time progresses. Whether what is your carbon footprint? Are you carbon neutral? Are you following a net zero pathway? So there's fundamentally a difference between what we used to talk about as carbon neutrality and now what we are talking about as net zero. In simple terms, carbon neutrality means whatever you are emitting to the environment, you are offsetting by some other things. Like you're planting trees somewhere, you're doing some other activities where you're offsetting the carbon emissions, but you continue to emit the carbon in the way you are already doing or the way your business is progressing. Now, what net zero means is basically you look at your business processes to make them more efficient, more cleaner, low carbon pathways so that your emission itself has an absolute reduction for a particular time frame, and only the residual carbon footprint which remains after following this decarbonization pathway is offsetted using carbon sequestration or carbon offset mechanisms. So that's the fundamental difference where the world has moved from being carbon neutral specific to net zero specific. And that's where industry is moving, that's where large corporates are moving, and I'm sure your customers would be asking you this, and that's where all of us as SMEs, as MSMEs, everyone in the industry start aligning our businesses to this particular requirement. So I have already mentioned about and explained what net zero means, and let's look at how can we get there. So basically reaching net zero emissions means removing equal amount of CO2 from the atmosphere that we released into, and therefore being more on a carbon neutral or carbon negative path. Now, despite of our growth in sustainable technologies, we have still seen that the carbon emissions continue to happen. And what we are doing basically is demonstrated is not enough for the earth to sustain this kind of developmental activities. And therefore, urgently, there needs to be a coordinated global action on this, and within the next decade, this combating of growth related emissions have to be taken very seriously by industry so that industry is not the sole responsible for these kind of emissions and the increase in the temperatures that we see at the global level. Now just look at this graph. What do we mean by climate change? See, what is projected today is by 2100, there would, if we pursue our current policies of development, we would be at a global warming to between 2.7 to 3.1 degrees Celsius. And you can just imagine the kind of havoc this will create in the world. To many island nations would get submerged because of the global warming and rise in sea levels. And therefore, it is imperative, and the agreement in Paris, which happened by the participants of the Conference of Parties, agreed that the world needs to follow 1.5 degree scenario, and that's the lowermost graph that you can see here. We need to take policies which will bring that graph, which is today projecting a warming to 2.4 degrees Celsius, to 1.5 degrees Celsius. And it starts right at the choice of our designs and what we are choosing as materials, what we are choosing as processes, what we are choosing as fuels. And it is at that level that we need to start tackling this problem to get ourselves to a low carbon pathway. Now, one more perspective and you'll get the picture. See, we are here and we consume resources from the earth. Now look at this graph, and some people here would have seen this. What we call as the Earth Overshoot Day. What does this mean? There is a certain natural resource generation capacity of this planet. And these resources are being consumed by humans, by industries, and everything that humans do within this, their sphere. Now, if you see this graph, in 1971, the amount of, or the capacity of the earth to regenerate resources, we were consuming over a period of around 12 months. What is happening today? We are finishing it, that capacity, by the end of July. There was only a very small blip in the pandemic year, where slightly this had risen to the end of August, but again we are back to normal. The new normal, but this is not the new normal. In terms of consumption, we are gone back to our old normal. And therefore, we are basically drawing resources which are meant for our future generations. And we are putting them in debt. And so we need to focus on how do we efficiently manage our resources and utilize them. So when we talk in terms of business or contingencies, what we say is we can have, if a plan A fails, we have plan B. Now we have to understand here, we do not have a plan B and we do not have a planet B. It's the only planet we have and the only planet that we habitat. And therefore, this is the only action that we can take to move our industries to a more responsible manufacturing and production processes. And when we now talk about net zero, it's not only carbon. We talk about 4 elements of net zero. It's energy, water, waste, and carbon. And you would have heard about moving towards low energy or zero impact energy, more renewable energy, water neutrality, water positivity, reducing water consumption use, waste recycling, circularity, that is basically bringing in how do you upcycle the material which is called as a waste. Rather than creating value for what you are generating as a waste, instead of terming it as waste, make it as a byproduct, make it as a raw material for other processes. And there's a requirement of a certain amount of extra effort that we need to put to identify this and also try and see alignment with other industries where this can go as a raw material. And carbon we already have spoken about. So if we move ahead, and I'll now come back to a little specifics on foundries because we are talking here for foundries. Now for foundries, what does it mean to be environment conscious? So foundries need to reduce basically the emissions resulting from their processes. This is the first. And I have already spoken about emissions and its impact. They are negative and potentially irreversible consequences for the environment. And so we need to actually adapt. And basically, new technologies, not only to continuously comply to the evolving environmental regulations, but we also need to go beyond. And what we need to satisfy is the global and societal requirements on this, on the emissions. And with that, what does sustainability for Foundry means? We need to look at the product life cycles. The product life cycles are the true measures to see so that what we are choosing as our process, I mentioned, as our suppliers, as the source from where our raw materials are coming, and how are we basically processing them, and how are we using these materials, how responsible we are at that, so that it supports our ecological, economical, and social goals that we set forth as industry, as globally as industry, and individually as individual manufacturers. So with these expectations, we need to look at the sustainability in foundries and casting industries. Now I mentioned about the focus areas. What you can do is look at your energy usage. So it is a proven fact, basically, that foundries are very energy intensive. We know that there are many processes, and foundries also part one of those industries which are energy intensive. And there is a lot of, they need a lot of power to carry on their activities. But at the same time, there are actions that you can take to responsibly look at this power consumption. You will need to choose probably many activities, and just a few I've mentioned is, look at the right melting and dosing furnace solutions, or look at where you plug leakages. But all this starts by doing an energy audit in your premise. Unless you start with that, you'll not identify those hotspots where you can take action. So that's the beginning. If you've not, I'm sure most of you have already begun this, but if you have not, and you are grappling of where do I start, do an energy audit of the premise. Believe me, it's an investment, it's not a cost. Because the moment you realize where do you want to begin, you can strategize and plan actions in a very time-bound and specific manner where you will have an impact on reducing of energy consumption. The other important area that we talk about as an ecological indicator is water. Wherever there is water use, again, the same philosophy goes: avoid leakages, plug those leakages, optimize your use, measure it. Unless you measure and monitor, you can't improve anything that you're talking about. And therefore, the first step for conservation is measurement. So begin with measuring. Look at what theoretically you should be needing and how much you're really needing, and then look at those areas where wastages are happening and start plugging those wastages and leakages, and you'll get better performance in terms of responsible resource consumption for water. Waste, I spoke. Yeah, I think I cannot elaborate the point more better than what we are experiencing just now. So it's hitting us, it's impacting us. So I think that drives home what I'm trying to say. Yeah. So I was talking about the waste management. Now, again, look at the entire process flow. What are those outputs which are coming out from every stage of your process? And then you look at the quality of those products or the outputs that are coming out, and whether you can see that there are alternate use for the generated waste, and whether there are other industries who can synergize with you in terms of utilizing this. So in fact, what I'm trying to say is you convert your waste to raw material for other industries. And that's how a circular economy performs. It's not extract, use, and throw. It is you use for your process, you look at other industrial applications, and again reuse. So it's a cradle-to-cradle approach that we say, and when we talk about a life cycle approach for anything that we do. I spoke about preservation of resources, and there is one example I can give you is, there are material which are rare, there are material which are readily available, and then seemingly there are material which are plentiful. But any of this material, it is very important that we responsibly consume that. And one example I can give is of lithium. Today we are talking about lithium, and lithium is required for the electric fuel cell production. And it is extracted from ground at a very grave environmental impact, which is happening in South America, where mineral reserves are being exploited to supply to the dramatic increase in the demand of lithium to service this industry. Now, are we doing it sustainably in doing that, or are there options we can use instead of this? So there are now advancements in development of lithium-free sand additive products, and these solutions are now available globally, and people are moving towards these kind of products. What I'm trying to highlight is, if you look at an analysis at a life cycle level and identify those hotspots, you can then focus your attention to opt for or use alternate solutions for those hotspots. And when you're choosing a solution, again, do a comparison of the life cycle impact of those solutions and choose the most cleaner options from this. And that's the methodology or hierarchical methodology that we should adopt for moving towards alternatives which are better or cleaner. Now, in terms of aluminum as one of the metals which is used, it is virtually 100% recyclable. In fact, global estimates are that nearly 75% of the aluminum that has been produced are still in circulation. And there's therefore a lot of demand for, with a sustainability perspective for this particular metal or material, and it having a distinct advantage from this perspective, because it has other properties, but this is one of the important factors where industries are moving towards more use of aluminum because of the recyclability. So I was saying recycling. One aspect is leveraging your in-house recycling. Now, in-house recycling offers several important benefits. It basically helps you utilize all chips, returns, all the scrap which is generated as byproducts for finishing, or either you internally use it or you sell it out. I'm sure you must be doing that for economic benefits. But now you need to start into perspective the environmental and ecological benefits in doing this, and that put a value to it when you make a decision. And therefore, this is also an opportunity to eliminate, maybe there are possibilities of eliminating certain purposes when you do that, certain processes, and you are optimizing your process efficiencies and the activities or energy that you are putting into processes. Oxidation and metal loss, I think I don't need to tell you all, but when we talk about aluminum, this is also highly recyclable, but it is susceptible for oxidation, and many alloys, aluminum alloys, oxidize relatively quickly compared with other metals in both solid and molten forms. And we all know that the dross caused by oxidation of aluminum is a challenge for foundries, which are seeking to improve their sustainability performance. Now, we also have a fact that out of this dross, only around 50% is getting recycled today, and the rest of it is landing into landfill. So it's a huge loss of resource. Now, what do we need to actually attack here is the oxidation part. So we go back to the root cause of the problem and see whether there are options, there are technologies, or there are process changes available so that you minimize the oxidation part which is happening, which is leading to a huge impact in terms of waste generation and loss of resources. Waste, I think this is a very important topic we all face today, and foundries, like, there are slag waste both from the cooled, air-cooled or water-quenched processes, and basically this can be used for making fines as well as coarse aggregates according to its strength. And we have tried this out in my company. We're trying to look at alternate materials as construction materials instead of using extracted sand or aggregates, and I think these are certain options that we are ready to look at. We have been experimenting. Also, foundry waste sand can be used in various applications as raw material for making bricks, blocks, structural fill supports, as soil, pipe bedding, trenches, sewer lines, many applications in construction industry. The sand should, obviously, what is requirement? What does that industry requires? That the sand should be clean, it should be free of contamination. Actually, this can be achieved through source segregation and discipline at the generation point. And that's where it is important. If a material is preserved and not get contaminated or mixed, it has a higher value for alternate use. Otherwise, there is an effort required to segregate it and not worth the effort. And therefore, then it becomes a waste and gets thrown at places where it should not be. And very important fundamental thing for waste management or upcycling is that source segregation and keeping it separately and clean from contamination. So I was mentioning clean or mixed waste is basically of no use to the future user, and therefore mixing actually decreases the value of potential for recycling as raw material. Now, sometimes refractory bricks are generated, which are again old, and it needs to be replaced. Again, this has application in construction industry after crushing. We are looking at recycled aggregates as one of the raw materials for concrete production, and I think this has value over there. So you need to explore these synergies with different industries, not only within foundry industry, but beyond, so that the material which is generated can potentially go as raw material for these applications. Coal-fired burner has bottom ash, and that also can be recycled. We know the power plants are recycling fly ash, and why not this? So we need to look at the qualities, and it can be studied whether the slag or the bottom ash has enough amorphous silica content in it, which has a cementitious property, and it can go along with the cement in production of concrete. So alternate uses are there, and these are examples of circularity. And waste disposal has its cost. Industry need to pay for it. And if we are not paying for it, the society is paying for it. Indirectly, we pay for it because of the disruptions it basically causes in many extreme weather conditions. One of the example is Kolhapur experiencing these floodings in last few years. It's not only Kolhapur, it also is in Mumbai. We experience this every year. And largely, waste or flooding is been attributed to the unlawful disposal of waste in the places where it should not be. It blocks water drainages for the cities, and therefore this loss is happening, which is an economic loss which happens because of flooding every year. Energy we spoke about, so I won't go very details into this. I'll leave the presentation, you can have a look. But I think this is a focus area where Foundry as an industry need to focus. And this is one of fundamental element on sustainability. And there are different areas where we can look at. I've mentioned a chart here where there are 7 focus areas that you can look at. But I want to summarize that furnaces can be converted into cleaner fuels. You need to look at actively at a clean fuel transition. Instead of coal, can there be gas-fired burners? Can there be gas-fired or other alternate fuels which are cleaner in terms of CO2 emissions? Often low-grade coal has a high content, more ash generation as a waste, and heavy metals, and they are also high on emission of sulfur dioxide because of the high sulfur content, and therefore they are more polluting, and the drive to move towards cleaner solutions is because of the quality of the coal. Efficiency, building in efficiency is an important aspect for fuel utilization. And there's also heat recovery mechanisms which are there. So if there are releases of heat, those can be captured and utilized in other aspects. And heat recovery is a system which many industries are now implementing in terms of improving their energy use efficiencies. Furnace lifespan is again important. The more often the equipment needs replacement, it is less sustainable. When we talk about circularity, there is one aspect in circularity which talk about is extending the lifespan, refurbishment, using the product that you have for more and more time. And these are all factors which are contributing to circularity or circular economy. And therefore, we need to look at maintaining our systems to a method where it is lasting us more. It is economically also beneficial, but at the same time, it also helps you in sustainability, especially in energy efficiency. And we also know a very poorly retrofitted or a poorly refurbished system can actually be a more energy guzzler than actually serving our purpose. So let us look at the life cycle cost. It's not only the upfront cost. We need to look at the entire lifespan and its cost that any system is going to give us in terms of energy use efficiency. Refurbishment of old machines, so extending this further, we need to look at systems for use more and for more years in terms of material conservation point of view, but at the same time take a call to look at this in terms of the energy usage. So a very simple cost-benefit analysis in terms of replacement versus a new system, but with the perspective of sustainability, with the perspective of life cycle cost as well as life cycle emissions. So what companies are today doing is putting a cost to the carbon emission. And when you do payback calculations, this cost is considered as essentially one of the factors in ROI calculations. And believe me, most of the times the ROI calculations change when you start putting a price to carbon. And I don't see the day is very far when this carbon emissions for all industry will be priced at or taxed. So therefore, I think it is now time that we need to get to this and sensitize ourselves and promote our process efficiencies in a way that we start reducing our inherent carbon footprints so as to make our businesses more economical and more sustainable over the future. So very briefly, process efficiency. There are two processes we are talking about. One is on automation, and I think there's been a lot of talk on automation, and I would not basically go much into this. But essentially what we are saying is automation, digitization, and AI, Industry 4.0, all these systems are helping us gather data, which is so intrinsic to our processes, which a few years back down the line, we were not even aware about. One example I can give you is when we started this in our industry, implementing 4.0, the workers used to feel that certain machines, when they are idle or there is no work happening on it, they are not consuming energy. But the moment we put sensors on those machines, it was realized that machines consume energy even in idle state in certain portions. And therefore, the behavioral change on the shop floor, that the moment you have finished your work, to switch off the machine, I started implementing, and that is giving us great benefits in terms of improving our energy efficiency. What I'm trying to say is, unless you have the data or the insights, which you can gather through these systems of artificial intelligence, through IoT 4.0, or having those dashboards on, with you as decision makers, quick actions cannot be taken. When you take quick actions, you are able to plug in losses very quickly, attempt to do that, and therefore, in the long run, you are actually conserving a lot of resource because of early plugging of those losses and overconsumptions or erratic consumptions that you come across. Also, make your processes easy. Make those places which are inaccessible accessible for maintenance. Good maintenance of machines improves its productivity, and I think this is very basic to engineering, and therefore, but sometimes we lose the focus when we are in a rush for production, but have very specific programs on this too, and this in large way contributes to your sustainable processes, to make your processes more cleaner and sustainable. So going ahead, all of us need to focus on a low carbon pathway, and while doing that, we need to look at our energy conservation. There are many things that you can do. You can do enhancing operational efficiencies. You have air compressors, you have HVAC systems in your system. Look at upgradations. The technology is evolving so fast that even the evolution of these systems within a certain time frame gives you good payback calculations and great energy efficiencies. Look at process efficiency improvements. I spoke about choose chemicals or processes which are low carbon and low energy. Efficient equipments, pumps, motors, and all these, I think all of us use very large way. But what is essential is to do an energy audit of these equipments and identify those equipments which need replacement because of high consumptions of energy. And very low-hanging fruits like efficient lightings and your systems within your premises, which is going to, over the long run, give you a very high energy efficiency or lower consumptions of energy. Adapt renewable energy sources, may it be power, wind. There are so many options, and we saw the Toyota presentation. There are so many options today available, which makes this more and more affordable to everyone. So look at those options. Group captive, there are PPAs, there are off-site productions. You can buy RECs. Look at those options so that you're transitioning your processes more and more towards renewable energy. If you're not able to transition your thermal process to renewable energy, the approach industry is taking today is moving more and more towards electrification, and then moving that electrification towards a renewable energy source. So wherever it is possible, move the processes to electrification and hence adopt renewable energy sources for that. Water consumption I spoke about. Do a water audit of your premise. Use low flow water fixtures, efficient fixtures. Treat your water and utilize it. Today, there are technologies we can make water 100% recyclable, and therefore, please adopt that. Zero liquid discharge should be a mandatory thing for all industry. I don't think this needs to be mentioned in a sustainability presentation anymore. But maximize the recycling in your processes and other applications within the premise. Use nature-based solutions. Treatment of wastewater also has an impact, also has a cost and a consumption of energy. If it is possible, please use systems which are nature-based, and there are solutions today available which are nature-based, which don't consume energy. So opt for them wherever possible so that your treatment plants do not consume energy further. Maximize rainwater harvesting, percolation to the ground, or use back in your processes. That will put less burden on the water supply that is either extracted from the ground or which is supplied by the municipal corporations or authorities. Rainwater harvesting, I spoke about, don't want to go into elaborating, but also work with the community surrounding you. If you're extracting groundwater, it is essential that you sustain that aquifer from where you are drawing. And to sustain that, you need to work with the community, because basically if you're over-extracting, taking the right of the community to have access to that resource. And therefore, we need to be very cognizant on this and do our part in terms of mitigating this impact because of our withdrawal. And waste recycling, I spoke about. Go to the minutest level of material that you are using. Do a mapping of materials that is getting used in your process and see alternate ways of recycling or upgrading them, right to the point of municipal garbage, which has still a huge potential of segregation and recycling. Just to give an example, we have a campus in Mumbai in Vikhroli suburbs, which is around 3,000 acres campus. We generate every day around 10 metric tons of just municipal garbage. And that is over and above the industrial waste which is generated. But since 2014, this entire waste is been handled in-house, recycled, and we see that there is not a single gram of this waste going to the municipal dumping grounds in Mumbai. So if it can be done at that large scale, it can definitely be done at every level that we are looking at. What we need to do is have a consciousness about this generation and how do we responsibly handle this generation. Yeah. We all need to align to a sustainable future, and you all know about the Sustainable Development Goals, which are put forward by the Paris Agreement, and businesses are today aligning to this. Very shortly, you'll see your customers asking you about alignments to these Sustainable Development Goals. But there are many challenges, and we all know that we have a frequently changing regulatory frameworks on environment. It is an expectation that if I'm giving a sustainable product, it should draw a premium, but it doesn't happen. This is basically now a hygiene factor, so stop expecting that premium for a sustainable product. Resource availability risk is something that all companies need to be cognizant of because of climate change and action. You need to take a risk-based trade-offs in terms of choosing alternatives. You need to choose green solutions for a green solution. You need to evaluate green solutions also on their environmental impact and make a right choice. There needs to be skill set development in the team, and using sustainability or green factor in your supply chain or what you're talking to your suppliers is very, very essential to make the entire value chain green and basically de-risk your as well as your suppliers' operations. So here's in detail I've given basically what you can do as individuals. I'll leave this, I think we're short of time, so I'll not go into this in detail, but everybody can play a role in this. There are systems, processes, monitorings and actions that you can take at various levels where sustainability needs to be a mainstream bedrock for your decision making. People in design, R&D, new product development play a very important role because we are talking about sustainability starting right at the concept stage. And therefore, when you're adopting these lenses for your future product development, it becomes more and more better. One simple thing, the cost of abatement is much more than the cost of avoidance. So when you're avoiding the impact, you're incurring much lesser cost than you would impact for abating that impact. Then you have sourcing and procurement. I mentioned you need to push the supply chain to be more and more sustainable. Here are some indicators. You can have a look at that and start taking actions from your side with your supplier base as well. Production and manufacturing is the core, and I don't need to elaborate more, but even HR can play its role in terms of how do you drive sustainability in your businesses. And marketing and sales, very important. How do you leverage your activities or your actions so that you can convey that message to your customers and help them make a more informed and a better choice in terms of products. And therefore, I think with that, I thank you for your time and patiently listening to me, and I hope whatever I have said has added some value to this, this great conference. Thank you, IIF, the Western Region Conference. This is the first time I am attending this. I just like to say that I have a very personal connection to Kolhapur because I've done my graduation from the KIT's College of Engineering. And therefore, it was very heartening for me when I was asked whether I can address this, and I immediately agreed to that. This is the main reason. I hope this has contributed in some way to the listeners over here. Thank you so much.
Thank you, Tejashree ma'am. I'm sorry I would have to cut you out for some 2 minutes or so. I hope everybody is waiting for the lunch, but then a few questions are welcome. Uh, I thank Tejashree for having given a very big journey right from the baseline of global warming and how it is related to the today's industrial revolution and how we have to maintain and improve on environmental sustainability. And she has raised the bar of responsibilities for all the industries, right from the large, medium, and small. And she has rekindled all our thinkings. Knowingly, unknowingly, we have been doing a lot of things in our own companies, but now it's with a specific agenda and with a specific targets, we should be doing this. Thank you. Please, questions.
Ma'am, this is Sushil Sharma from Nagpur. Your command on the subject was commendable.
Thank you.
I think she
Thank you.
deserves a big round of applause for the
Thank
subject.
you, thank you.
Ma'am, you spoke about the ash generated in the power plants. The floater ash, we all know, is having a good application and even having the export market. But when you talked about the bottom ash has been used by the cement manufacturing companies, and the OPC grade of the earlier grade has been converted to the PPC. Though the OPC was a fast-setting cement, but PPC is a slow-setting cement. But the final strength of the PPC cement is very high as compared to the OPC.
Yes.
So other than that, but the amount of ash generation, particularly the bottom ash generation in India, is so high because of the ash content of our coal, Indian coal is so high. Apart from this cement application or even the road construction, what do you think that there can be other useful applications for the bottom ash?
Yeah. So I think we need to explore in terms of other construction materials. You would have heard about blocks, building blocks. You would have heard about paver blocks.
I think, ma'am, still it is not sufficient. The kind of
I understand.
amount, yeah.
What I'm trying to say is, what example I was giving is, a generator needs to look at alternate industries and not just try and see how you can do it within the industry. You are right, the quantum of waste which is generated is much higher than what is getting utilized. But also what happens at times is the logistics or the ecosystem development. There are areas where it is required, but it is not reaching. That also happens. So when we are looking at disposal, we cannot just look at in the immediate neighborhoods. We will need to look at the whole ecosystem development. We will need to look at what are those partners who can convey that material from one place to other and help in applications. I am not able to give you a very particular example in terms of other applications, but we have been very extensively using fly ash in our solutions for construction.
Any research going on or the...
Lot of research is going on. In fact, construction industry is one of the most carbon intensive industry over its lifetime. Not only in the operation phase, but also as a material. It is looking at decarbonizing its material, and largely it is cement, steel and other materials which are very, very high in embodied carbon. So the whole industry is looking towards decarbonization in terms of carbon capture. Even for curing of concrete, we are looking at capturing the carbon and utilizing it for the curing. Now the challenge again here is, from where do we capture this carbon dioxide? It has to be from a point source generation. And when we are looking at point source generation, we are looking at then industries who are having point source generations. So it may be a steel plant, it may be others who are having very specific emissions, cement plants. Now, the work is going on developing that ecosystem where this CO2 emissions, which are currently as an emission, gets captured and channelized to concrete manufacturing. So that when the manufacturing of concrete is happening, CO2 is induced in the concrete manufacturing. Instead of a carbon guzzler, it becomes a carbon sequester. And over its period, concrete also has carbonation process by which it is capturing carbon. It's a slow process, but it's still there. So likewise, readily, I can't tell you any other application right now, but there is a lot of research going on in many industries for decarbonization. And you would know that there are 17 industry sectors which are highly polluting and heavy on carbon emissions. You would have heard about the PAT scheme, which is perform, assess and then trade your emissions. So likewise, today it is for 17 industries. It is going to get expanded to more and more industries who are having carbon footprint. And at that point of time, we start looking at alternate solutions where instead of emitting or emissions, we start converting it into as a raw material for infusion. So I'm not able to tell you a correct example right now, but I can very surely tell you we are doing a lot of research. The whole construction industry is coming together along with steel and cement industry to look at what could be other alternatives for these material, because cement and steel both have material which goes into concrete making. There is slag, then there is ash, both. But now when we make a choice, we are also looking at the life cycle approach of both the materials. And what is the efficient way that they are processed, and how less are they on embodied carbon. And both these industries along with construction industries doing a lot of research on this. I can assure you that, because we are part of those associations where this research is happening.
I will just share my contact number. I will be in touch with you.
Yes, sure.
Thank you.
Thank you, Tejashree Joshi ma'am. As you rightly said, there is no planet B. So your inputs will definitely encourage Foundry men to take a pledge on preservation of resources. And I can proudly say, today, I have Kolhapur chapter, Foundry clusters, along with Shivaji University, are working upon different aspects of waste recycling and circular economy. Thank you.
Thank you so much, ma'am. And now it's time for the felicitation. I'd like to request Session Chairman Mr. Ravi Dori, Castco Kolhapur, to come forward. Our speaker, Ms. Tejashree Joshi, Godrej Boyce Manufacturing Co. Limited, Mumbai. Can we have a round of applause? Now, lovely ladies and gentlemen, it's